Hello, students. This is Dr. Faizan Mirza. I'll be discussing questions regarding control and coordination with you in this particular video. I have picked up two questions here. They both deal with the nervous control. The first question is from May, June 2015, and this is from variant 52. So this question gives you a set of apparatus which you might not be familiar with, which is something that you should be expecting in your P5 because the examiner is not bound by syllabus content. There will be questions beyond your syllabus. There will be questions from AS or A2 or something at a tangent to the syllabus and extension. So all the description necessary to process the apparatus and how it needs to be used will be provided in the paper. If it's beyond the syllabus, so the description will be there. So in this case, the NCV test is shown to you. This description is already provided in the question because you might not be familiar with this apparatus because this apparatus is not exactly is exactly not the part of your syllabus. So the speed at which the electrical impulse travel along a nerve can be determined by carrying out a nerve conduction velocity test. So they give you general information. Now they are giving you more information. Surface electrodes are placed on the skin over the nerves at various locations. They produce a very mild charge which stimulates the nerve. Figure 2.1 shows the NCV is measured in the ulnar nerve of the human forearm. I will skip this part for now. So you can come to the diagram. This is the human hand shown, and this is the forearm. And you can see that this thing labeled is a surface electrode. What is a surface electrode? They already have told you what the surface electrode is. It will produce a tiny current, tiny charge, and it stimulates the nerve. And furthermore, it says the resulting electrical activity in the nerve is measured by a recording electrode. So the other electrode here should be the recording electrode. The distance between the electrodes and the time it takes for the electrical impulse to travel in them between them is used to determine the nerve conduction velocity. So this is the distance that the electrical charge will be traveling through, and the time taken for this to reach from the surface electrode to the recording electrode. The time will be recorded, and the time can then be displayed, for example, in seconds or milliseconds, to tell you how quick was the nerve conduction velocity in different individuals. So you can just decipher what the diagram mean using the description provided. Now the questions further on tells you an investigation to measure the NCV in the ulnar velocity ulnar nerve in females of different ages was carried out on 394 individuals. Now that's a very large number of samples that they have taken. So 394 in this case is your small n. The total number of samples that you have taken suggests three variables that the investigators should have standardized. Now, if there are 394 individuals, so the same arm should be tested. For example, the dominant arm of all, or the right arm of all, or the left arm of all. So it needs to be standard. The arm must not be moved. It should stay in one position. The subject should not move the arm. They should be of similar body mass. They should make sure that they are not using any kind of a stimulant, for example, or any kind of depressant, for example, alcohol or caffeine. And the distance between the electrodes should stay the same. So yeah, the distance should be maintained. This is a control variable. So you know the time taken by the by this for the charge to move from surface electrode to recording electrode is mainly because of the movement within the ulnar nerve and not because of the distance being changed. So three variables out of S could be picked and you need to mark that. Furthermore, they say table 2.1 show the results of this investigation. The age and category is mentioned to you. Mean conduction velocity is shown to you. SM. SM stands for standard error. Confidence limits, lower limit and upper limit is shown to you as well. I have already discussed with you what basically standard error is. It tells you that how close your mean is to the calculated mean is close to the true mean of the population. So that basically is the standard error. The confidence limits are calculated using mean plus minus twice the standard error. So the description is given to you, the table is provided to you, you have to fill up this table, these two values. So use the formula and fill the missing values. What do? You already know the mean of this particular age group is 52.2. So you know the 50, this is the mean there. So this is your mean there, and with the mean we are provided with the value of standard error. So this is the standard error. According to the formula, you have to multiply the standard error by 2. So standard error is 0.675, you multiply it by 2, you get 1.35. Now this particular SM form, the confidence interval formula tells you that you have to add the mean here in the place of mean, and then there's plus minus, and then twice the value of standard error. So twice the value of standard error comes out to be 1.35. It means that you have to add and subtract twice the value of standard error from it. My twice the value of standard error to SM came out to be 1.35. So what I'll do, I'll add 1.35 to 52.2, and I'll subtract this as well. So I'll get a lower limit and an upper limit. I'll write them appropriately at their places. I'll use two decimal places because all the values provided to me are in two decimal places. So my answer comes just perfectly. One conclusion from this data is that mean conduction velocity in the ulnar nerve varies significantly with age. Identify two age categories in which appear to support this conclusion and give a reason for your choice. Now, if you start to compare, they say the age is a significant factor causing the change in velocity or the nerve conduction velocity. So different age groups have been tested. So if different age groups have been tested, so how do you know whether the difference between the nerve conduction velocity in different age groups is significant or not? So the different age groups, for example, if you compare the first age group with the last, or the second with the last, or the third with the last, or the fourth with the last. So the last one is the most aged group. So you can say that if you compare any of these with this particular age group of 70 to 79, you see that the confidence limits, they do not overlap. They do not overlap. The lower limit of one and the upper limit of one are not overlapping. There is no overlap there. So in this way, we can say, because we know that we can see that the lower limit ends at 51.90. It begins at 51.90 and the values goes up to 56.7, whereas the lower limit here begins at 46.85 and the values continue to 51.15. And after that, there is a gap, and only then you will have 51.90 ahead on this line. So there is no overlap in the lower limit of this particular age group and the upper limit of the other age group. So when there is no overlap of the SM values, it means that the difference or whatever you are seeing is actually significant. The difference here is in the nerve conduction velocity, and age is a significant factor contributing to that particular change. Now, for example, if the nerve conduction velocities were overlapping, if the lower limit of one and the upper limit of one were overlapping, then the difference would still be there, but the difference would not have been significant. We move on. State which statistical test would be used to confirm this conclusion, and give a choice for your reason for your choice, the reason for your choice. So the test here will be t-test. We know that t-test, it actually is used up when means of two sets of data are being compared. We already know that means are calculated for the continuous data only. So wherever you have continuous data and means are being compared, so you can use t-test there. State the null hypothesis for this test. In null hypothesis, we state the statement and we say that there's no significant association in the variables being studied. So what will be our null hypothesis? There is no significant difference between the nerve conduction velocities in all the age groups. State one reason why the results of this investigation were considered to be reliable. They have taken a very large sample size and they have used the same protocol with everyone. So yes, this should be quite reliable. Now, the other question that I've picked is from May June 2017. It's from variant first variant 51, and the question here deals with us with again a hypothesis. And here the student used the internet to find the information about caffeine and the possible effect it has on the body of an individual. The student decided to test the hypothesis that caffeine decreases the reaction time and increases the heart rate. So caffeine is being consumed, and the reaction time as well as the heart rate. These are two variables which actually which actually in every individual will be tested. So the reaction time will decrease and the heart rate should increase. This is what the student hypothesized. So this is a hypothesis. This is not a null hypothesis. This is a hypothesis because he or she says that the association exists. So table 1.1 shows the results of the students' research into the caffeine content drinks. This is already given to you. How much caffeine content milligram is there in a cup of coffee? 80. In cup of tea is 40. In 100 cm of energy drink is 30. In cola, it's for 350 cm cube cola, it's 45. So the student knows how much milligram can be given. The student also found that it takes about 45 minutes before the caffeine from the drink is fully absorbed into the blood and about 4 to 5 hours for the effects to wear off. So this is the time provided to you. So you need to give the subject a particular drink of caffeine, either of these, and then wait for 45 minutes for its effect to start kicking in. You don't use the term kicking in though. So you just wait for the effects to be shown on that individual, and then you start to note down whether the heart rate is changing or there's a reaction time being decreased or what. and the person must not have consumed anything of these caffeine sort in the last 4 to 5 hours, because the previous amount of caffeine would still be circulating in the blood. So after further research, the student decided the test subject should not know whether they have a drink with caffeine or without caffeine, because when the student when the subject would know that, okay, I'm taking caffeine, the student his or her own expectation will start to affect the outcome of the result. That, okay, if it's caffeine I've consumed, okay, it's supposed to increase the heart rate and decrease my reaction time. I need to respond quicker. And if I'm not taking caffeine, okay, I can be a bit slow. So the student's expectation can actually can make the results less reliable. So this is exactly what they have asked. Suggest why it's important that such test subjects should not know whether they are having a drink with caffeine or not caffeine. So the outcome of the test can be affected by the subject's expectations. So you get a mark there. Drinks with caffeine and without caffeine should look identical, again, to make sure that the students or the subjects do not know which they are consuming. To measure the student's reaction time using a computer program that flashes a colored light at random intervals, the light being colored, the light showing at random intervals, make sure that the student cannot predict when the light is about to be shown, the flash is about to be shown. The subject presses a switch as soon as they see a light. So the switch is there, and the student will look at the screen, and as soon as the student sees the flash, the student press the switch. This is the reaction time. To measure the heart rate using a pulse meter attached to the first finger, so pulse meter is being used for heart rate. All the information is provided. State the independent variable and two dependent variables. So what is the independent variable? What's the cause the change in heart rate and the reaction time? It's the presence of caffeine. And what is the effect? The effect is the dependent variable. So it means the reaction time and the heart rate are the effects here. And these are the dependent variables. Okay, so the next part tells you use the information given to describe a method by which the student could use and could test their hypothesis using one of the drinks. Your method should be detailed enough for other person to use. So it's an 8 mark question. So you need to have a maximum of 8 points, and these maximum 8 points should include the variable, they should include the procedure, they should include the safety and the reliability as well. All the variables have already been stated, but connecting the variables to the procedure, that how the independent variable will be varied and how the dependent variable will be monitored. Some hint need to be given. Yes, more marks will be for the procedure, safety, and the reliability of experiment, and how detailed your plan is. So what do we know? We know you will pick any of these drinks. So pick any of these, and you take a large number of samples. You take a large number. For example, if you just state use a large, you test a large number of individuals, for example 50 individuals, or for example 100, a total of 100 per 100 individuals, and with these 100 you will have 50 males and you will have 50 females. So 50 males and 50 females, and you will just test them initially, and initially you will have each subject should come in isolation, and the subject should be the initial baseline values need to be taken, and you will note down the reaction time and the heart rate, both need to be taken, and the how the reaction time varies and the heart rate varies initially with no caffeine there. And it needs to be ensured that the person has not taken any stimulant in the last 4 to 5 hours. All your 100 subjects should either be all caffeine users who already are using caffeine, or all should be non-caffeine. It should not be a mix, because people who already are caffeine consumer will already be tolerant to the drug, so they will not have the same effect of this concentration provided to them as compared to the ones who are not tolerant to caffeine. So yeah, the person should be either non-caffeine taker or a caffeine taker. So all 100 subjects should be that way. So initially you take the readings of the heart rate and the reaction time, using the description provided. Then you give one of the drinks. So select any one and then stick to it. All 100 subjects should take the same. And they will be taking this drink, and once this is consumed, they will wait for 45 minutes. And once they are they have taken this for 45 minutes, what do? You just wait for 45 minutes, and then you retest them for their reaction time and the heart rate. And out of these 100 subjects that you have taken 50 males and 50 females. So 25 males and the 25 females are the ones who are taking the cup of teas, and 25 males and the 25 females, other than those, they are taking a non-caffeinated drink. So drinks with caffeine and without caffeine should look identical. So your half your subject should take caffeine, and half of them should not take caffeine. So you can draw a comparison whether the males and the females who took caffeine and the ones who did not take caffeine, are they having the same kind of reaction time or the increase in the heart rate as compared to before and after consumption of that particular drink. They should not know the expectation should be minimized, and that can only be possible if you wrap the drink in a glass in which the student cannot see what exactly is the color of the drink. So, or you need to just make a drink which is there in a covered jar or in a covered glass. So they just consume it and they do not know whether it's having caffeine or not. So that's called blinding. Only the experimenter knows what exactly is there the person is using. So once this is done, the procedure is provided, the procedure you have described. All the individuals should be of the similar body mass and age and size, and gender already I've discussed. They should be of the same ethnic background as well. So once you have this, you can take out the you can see the reliability will be there because already you are taking 100 subjects there. You can compare their pre and post results there. And since you are using this is actually the study on humans, so you have to take a consent. So the consent form must be there. A consent form tells that, okay, I have a right to withdraw if I feel uncomfortable during the plan of the investigation. And this is how the human actually studies are conducted. So that's what you need to make sure for. You can add for 8 marks. Now if you move on, they say in another experiment 10 subjects were each given a different concentration of caffeine. Subject 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they all are given different concentrations. The reaction time was measured 5 times. 5 times will add reliability for each subject, and a mean was calculated. So mean reaction times are shown to you. Mean. So 5 times this was done on the same subject. Subject 1 repeated this for 5 times, and that's the mean. Subject 2 repeated for 5 times, and that's the mean. This is what the table shows to you. The concentration provided to first subject was 0, second subject to 40, the third subject was 60, and every single subject was tested for one subject was tested for each concentration. So, for example, if you are testing for if the student tested 40 milligram, so only subject 2 received 40. If it was 160, only subject 8 received 180, 160. So subject 9 received 180. So there is no repetition there. So that is one of the factor which makes such studies non-reliable because there are no repeats and only one subject is tested per concentration. The total n is 10 because there are 10 subjects that you have taken. Figure the table, the graph shows produced by the computer program for the data. Mean ratio time is showed you concentration of caffeine. You can see the graph is coming down. What is this? This is the negative correlation. You can see there's a negative correlation there, and the line just goes here. And this is negative linear correlation, in fact. So because you can see, you can make a judgment by eye. How do you know this is a linear correlation? Because you can make the judgment by eye. The scatter plot. This is the scatter graph, and the scatter graph shows to you that yes, the negative correlation exists. So this is what they're asking. State why Pearson linear correlation is suitable for this data, because paired data is there, which is having normal distribution. The scatter graph shows a linear correlation exists, and you get a mark there. Furthermore, they say the result of statistical test gives Pearson linear correlation is minus r is equal to minus 0.722. That's the value. State this value indicate. What does this mean? What do you mean by negative correlation? So it actually means that the concentration of caffeine is increasing, the reaction time is decreasing, because as you increase the concentration of caffeine, the reaction time keeps decreasing. So this individual is having a high reaction time, and he or she had a low concentration of caffeine. The person who took the highest concentration of caffeine had a very low reaction time. So there's a so increasing the concentration decreases the reaction time. Next, furthermore, they are saying figure 1.3 shows a part of the probability table for the critical values of Pearson and correlation. Test R, number of pairs of data n is shown to you. So number of pairs of data, how many pairs of data you have. This is the paired data. Paired data, one value for the other for the first subject, the second pair, the third pair, the fourth pair. These are the paired. This is paired data. So how many pairs of data did the student take? The student took 10. So when we are using degree of freedom, how do you calculate degree of freedom? For a single set, we use n minus 1 because there are 10 subjects, so it's 10 minus 1, 9. Or for paired data, since they are pairs, so we can use n minus 1 plus n minus 1. So this will be 10 minus 1 plus 10 minus 1 giving 18. Both answer will be correct. If you are using for the single set, you will pick up 9. If you're using for paired test, you can use 18. Now, since it already says it's pairs of data, so it's safe to use the 9 value here. We know we take probability about 0.05, so our critical value comes out to be 0.602. We always pick 0.05 probability level in biology experiment because this shows 95% confidence. It leaves 1 in 20 chance of error. So what is the critical value? Our critical value comes out to be 0.602. What was our value of the Pearson correlation? It was minus 0.722. Now, since it's a negative value, we'll ignore the negative sign now and we'll convert it to a positive value. Now, if we start to put it there, describe how student probability will find out the R for 0.072 is significant. So you ignore the negative sign there. 0.722 value is smaller or greater than 0.602. It's greater. So we know that the R value is greater than the critical value. So whenever the R value is greater than the critical value, the effect is significant. It's not due to chance. So the intake of caffeine actually increases the reaction time. So yes, it actually shows this. So there's two reasons why the method used for the investigation into effect of caffeine consumption may not give the results that are not may give results that have that may not that might not be reliable. Subject 5 and 6 they show anomalous reading. Plus only one individual is tested for one concentration. If you go back to the table, subject 5 and subject 6, they don't fit the trend. For example, subject 5 took 100 milligram and got 300. So that's a value lesser than 320 fine, but then the sixth subject took 120, a higher dose, and he actually or she is getting 305. So how is this arise there? So this is an anomalous set of reading. Lastly, effects of caffeine in the body include promotion of acetylcholine release and the inhibition of the acetylcholine esterase. This is basic what content you studied. Acetylcholine esterase is the enzyme that breaks down acetylcholine and helps it with recycling from the synaptic cleft back into the presynaptic cell. So just how this could account for results in table 1.2. So this basically caffeine, what it might be doing. It may, for example, if it's inhibiting the acetylcholine esterase, it will ensure more acetylcholine stay available in the synapse and will keep on stimulating the synaptic cell, the postsynaptic cell. So yeah, that was a big question. So in P5 you have questions. The paper is for 30 marks, but yes, one question may be way longer as compared to the other. So you need to have a very good grasp at all the content that you have studied. I hope the video was helpful for you. So that's it from my side. Thank you so much.